Algebra 2, Chapter 5.4, Solving Systems of Linear Inequalities. We have our essential question: how can you represent solutions of a system of two or more linear inequalities? And then we're going to solve systems of inequalities in two or more variables. Okay, explore turning a system of equations into a system of inequalities. And we have this system of equations we start with, and if we draw lines on a coordinate plane, we have y equals x plus 2, where our y-intercept is 2, and with x, 1x, you have a slope of 1. So you're going to be going up 1 over 1. So your line is going to be looking like this. And then as we go to the left, so that's about as well as I can draw in a freehand. And then we have the second equation, y equals negative 2x plus 1. And so we mark a y-intercept at 1. And then we have our slope is going to be negative 2, which is going to be rise of negative 2, run of 1. So if we go down 2 over 1, and then down 2 over 1, and then the reverse process up here, up to the left 1, up to the left 1. So we're going to be looking like, there's our y-intercept, it's going to be looking like this. Okay, that's about as smooth as I can do. Yeah, how many regions do the two lines divide the graph into? Well, that'll be 4 regions total. Now, part C, consider what it means to replace the equal sign with inequality. Replace the top equation by the inequality y is greater than or equal to x plus 2. And for that, what I'm going to do is take this top equation and I'm going to draw a solid line over that. And how is this different? It means for any x value, the solution includes not only the corresponding point on the line y equals x plus 2, but also every point in the coordinate plane with the same x value has a greater y value than the corresponding point. So basically what we're doing is any point on the line plus any point on the coordinate grid that is above that line. So we have what I like to say equal to and greater than x plus 2. So that's basically it. Now, continuing on here, now replace the second equation with the inequality y is less than negative 2x plus 1. So I'm going to go back here to my sketch, and we say less than, and we say less than, it can be less than or equal to. So I'm going to make a dashed line over the other one. And we say less than or equal to, we're going to sketch below. And so to do that, I'm going to create a blue line below. So here we go. I'm going to crosshatch like this. Okay, so that's what the two hatches together look like. And so what you have in the solution set is going to be in this left quadrant, if you will, where we have both the red sort of vertical type hatches and the blue horizontal ones together. So our solutions are going to be in this area that I'm putting in green. Okay, full, and then dashed line up here above. So I've kind of circled all this area in the coordinate grid in green. This will be where we have both inequalities have their solutions in common. So I'll put solutions. All right. And so how many regions of the graph were shaded in both steps? Well, I'm not going to go ahead and elaborate any further. I'll just skip the discussion. Explain one, graphing a linear system of linear equations in two variables. And here we have one that's already marked out. I'm going to go on to this one here, B. X is greater than 3. Well, what you do first is, it says greater than. I would say, the way I would put this is not equal to and greater than. That's how I verbally say it. And I'll tell you in a minute why I do it that way. Okay. Not equal to and greater than. So we go to 3, and these things go by 2. I'm going to go back and revert to my this line here, and I'm going to fix the dashed line. And so not equal to this little dashed line here, vertical. That's key because you can't do that on your graphic calculator. It's dashed, but it's hard to see it. Anyway, it's greater than 3. So what we're going to do is hash in this area to the right. Greater than, not equal to, but greater than. Okay, the next one we have is x plus y is less than 2. And for this, we can solve for y by subtracting x from each side. So we have y is less than 2 minus x. So we have y is not equal to and less than 2 minus x. So here is our y-intercept, and then we have our slope of -1. So we're going to come like this, and I'm going to go get a dashed line here. I'm going to try to get a line that's a little bit bigger here. I'm going to try to go to a red one. Okay, I'm going to get one that's dashed and a little bit bigger than the other one. So it's going to be like this. Let me see here. Here would be a point, point, point. From here, go down. Okay, see how well. See if it's more, yeah, it's a little more visible with the dashed. Having made the line a little bit bigger. Okay, it's key where we cross their boundaries. And it's going to be less than, and so I'm going to shade this area here. I'm going to try to go a different direction. I'm going to go different directions, but I'm going to shade like this. Okay, where do we have the common area? Right here in that lower right section. Shade each half plane. The regions in both half planes will be double shaded. And it says sample. I'm going to go back to green to sample points. 4, -4 sample points. So 4 to the right and 4 down. Is this in the hashed area? Yes. Yes. And that's this one here. 4, -4. I'm going to just write 4, -4. That is part of the solution set. And 6, -6 So go 6 to the right and down 6. Yeah, that looks also to be in the set. Okay, let's see here. Does that look right? Yeah, that is right. Okay, next, your turn, and I'm going to invite the viewer to go ahead and see if you can work this number 2 and number 3 out. See what you get. I'm going to just pause. I'm going to work number 2. Okay, here it is. X plus y is less than 4. So solving, we're going to subtract x, so y is less than 4 minus x. That's plus 4 minus x. So we go up here to 4, and it's not equal to, but less than. So we go to 4, and our slope is -1, so we're going to be looking like this. And I'm going to get my blue dashed line. Here we go. There's my blue dashed line. And here we go. Okay, and we are less than. Y is less than. So for that, I'm going to go like this. Dash like this. Ends up being a dashed line, but it doesn't matter. It looks like this. So there we go. Hashed in. Next, y is equal to and greater than 2x minus 2. And so for this, I'm going to go get a red, in this case solid line, because equal to, greater than, so we have 2x minus 2. So we have -2 is going to be our y-intercept, and we have 2x greater than 2x minus 2. So we go down 2 over 1, down 2 over 1, and up 2. So we're going to be looking like this, and that's going to be greater than. So it's solid, equal to, greater than. So here we go. Slope of -2 and greater than. So we're going to shade up above this red line. So what is our solution set area? Well, it's going to be this area that I'm kind of tracing in green here, right? With the dashed line on top and the solid line on the bottom. So this skinny triangle looking triangular shape. Next, 3, we have 2 systems in close to standard form. There's another way you can solve this using the intercept method, and I don't want to overly confuse the issue, so I'm just going to solve for y. So if we add on the bottom one 3x to both sides, we have y is less than 1. I'll put 3x plus 1. So that's going to be the bottom equation, inequality, and the one on top, we're going to subtract 2x, kind of working up above, and add 3, and do the same thing on both sides. So we have minus 2x plus 3. So we have 2y, I'll just put here, 2y is not equal to, but less than negative 2x plus 3, and we divide both sides of the inequality by 2, we get y is less than negative 2 divided by 2 is 1. We get negative x, and then we have plus 3 over 2. It's going to be our y-intercept. So I'm going to do this bottom one first, and to do that, I'm going to take, I'm going to get less than, not equal to, but less than. So I have this 3x plus 1. So here's our y-intercept at 1, and then we go up 3 over 1. So up 1, 2, 3 over 1. So we're going to have this sort of looking part here. It's pretty good. And then we go the other direction, down 3. 1, 2, 3, and to the left 1. 1, 2, 3, to the left 1. So coming from the bottom, we're going to look like this. And we have less than, so that's going to be below, so I'm hashing this way. Okay, next we have this y is not equal to but less than negative x plus 3 over 2. For that, I'm going to go get my red dashed line and go to 3 over 2. Well, these are each by 2, so it's going to be slightly above the y-intercept of the other one. And negative x plus 3 over 2. So we're going to go down 1 over 1. So something like this. Down 1 over 1. Down 1 and 1. Down 1 over 1. Down 1 over 1. Something like this. Down 1 over 1. So that's what things will look like. 1, 1. Okay, that's what I was going to do. So anyway, that's going to be not equal to, but less than. So we're going to go like this. And less than. So we're going to be shading this area. Let me get a skinnier pen here. And so it'll be like this. We can see in this lower section down toward the right, this is the area of common solutions. So that's that one. So solutions down here. These are solutions here. This area. Anyway, that's it. I'm going to go, the next video is going to be some specific exercises from the homework assignment. I hope it's been helpful. Good luck, and thanks for viewing.